Okay, so today we're going to talk about limits. And so the way that we read this is the limit as x approaches this number, whatever number that is, this part means from the right side. And then of f of x equals whatever. This is going to be your answer. And so what that is saying is when x is doing this, what is y doing? What is the y value approaching? And the reason that we use the limits is because this is usually at a vertical asymptote and x is technically undefined. So we can't ever actually reach it, but we're going to say as we approach it from that direction, what is happening to the y value? And then this is very similar down here, but this minus sign means that we're approaching from the left. So let's look at some examples to see how we do that. So this is an example from the notes. It does have a hole in it, but I don't really care about the hole because the first thing says, what is the limit as x approaches 4? So here is where x is 4. Oops. Where x is 4, that is this vertical asymptote. So the first question is saying as x approaches 4 from the right, what is y approaching? So what are my y coordinates getting closer to? And so as x approaches from the right, so we're going from the right, we're going this way, and y is going, so x's are going left towards 4, y's are going down towards negative infinity. So my answer here is negative infinity. On the other hand, as x approaches 4 from the left, what is y doing? Well, from the left, as x approaches from the left going to the right, y is going up towards infinity. So this one is positive infinity. And so that's why rational functions are so interesting, because at a vertical asymptote, sometimes it can be going in different directions from either side of the spot where it's not defined. Okay, then we have as x goes to negative infinity. So as x approaches negative infinity, we're going, okay, I'm going this way, then the y value is getting closer and closer to the asymptote of 1. And as the final one is as x approaches positive infinity, different color here, positive infinity, we're going this way, and the y, again, is getting closer and closer to that asymptote of 1. Okay, so let's look at a different problem. This is an interesting problem because we actually have this thing called a crossover point. That's just where we cross over the asymptote, but then up here, we're going to approach the y equals 2 asymptote still. So it's not going to change a whole lot. So we're going to start with our vertical asymptote. As x approaches negative 2 from the right, what's happening here is from the right side, the y is going up to infinity. As x approaches negative 2 from the left side, y is also going up to infinity. So approaching from the left, y is also going up to positive infinity. And now when we say approaches negative infinity, we're saying like what's happening here, we're approaching this asymptote. So y is approaching 2 and going to the right. We already talked about that. Although it crosses the asymptote, again, it's going up towards that asymptote of y equals 2. So again, that one is also 2. Okay, on our final example, we actually have what's called an oblique asymptote, which means it is a slanted line. So this is called an oblique or a slant asymptote. So we'll come back to that in a moment. You'll see now we have two vertical asymptotes to deal with. So the first one is right here at x equals -3. And from the right, the graph is going up towards positive infinity. And from the left, the graph is going down towards negative infinity. Okay, so this one is from the left, and this one is from the right. Okay, and then at x equals +1, from the right, we're going up to positive infinity. From the left, we're going down to negative infinity. And then finally, for the going my x values to the left and right, as x goes more and more left, it's actually following this trend of this line, and it's actually going down. So it's going to negative infinity. It's not a horizontal asymptote, so it's not an actual number. The number keeps changing and getting lower and lower. And then as x goes more and more to the right, this number is going up, up, up. So it's going to positive infinity. So when you have an oblique asymptote, it actually goes to negative and positive infinity.